Thank you very much. Okay, so now we are going to turn back to some presentations. And we're going to start off right now with Jared Freeman, who is the chief scientist at Aptima.
Thanks. Down under Freeman. There you go. Yes. Now can I hold three things at once? No. Okay. So thank you for the invitation over, and then back up the chain. Thanks to DoD for sponsoring this organization and the conference it's managed to put on. I got to say, this is a bit of a blast back to the past in some respects. Those of you who are under the age of say 30 and are about to start research work in particularly cognition over software issues might look back to, say, the early 90s, to the programming psychology interest group, to publications out of the empirical studies of programming, for work on how software engineers represent complex systems, how they read code, because clearly there are experts in this area and novices, how they interact socially to maintain or debug systems that are so large, such as the telephone system, that no one person understands them all. There's a rich body of research there that comes out of cognitive psychology. Elliot Soloway, Deborah Baim Davis, Curtis Cook, Nancy Pennington, all really insightful folks in that area. So there's stuff back there in history. I'll talk about some rather recent history, which is a training solution that we developed with funding from AFRL, thank you very much, to help supervisors detect insider threats to cyber systems. Now, what I mean by insider threats here is any member of personnel, a service person, a consultant, a member of civilian staff who might harm the organization by way of one of its systems. They may harm that organization through greed, through resentment and malice. They might do it completely accidentally, right? The sort of issues we've been talking about a lot this morning. We know from various studies that each of these events is costly, at least in financial terms, right? We won't even talk about national security at the moment. One estimate was about $500,000 per incident. So that means everyone dealing with systems should, should learn to spot the signs of insider threat, only that's very hard to do because these incidents are extraordinarily rare, right? If you were to train on 10-minute scenarios in a manner that samples legitimate work behavior and insider threat behavior, you would have to do about 10 years of those scenarios before you had one experience with an insider threat. So clearly, yes? Yeah. Got it. Right. So clearly, we can't expect people to learn well how to deal with insider threats merely from experience. Some sort of training is probably going to help. Happily, it appears that a fair number of insider threat cases are observable from some sort of behavioral cue. Right? So this now begs the question, so what do we mean by cyberpsychology, right? What is the psychology that generates behaviors? And our basic framework for this, and we'll sort of structure the rest of this talk around this, is that there is a set of psychosocial states of folks who work in organizations. And there's an environment that may elicit some of the worst behaviors out of the bad states, right? So we think of there being a sort of psychosocial core, and there being an environment which consists of the organization, which may be very well designed and good to its employees, or really awful, right, and elicit bad behaviors. And there's a security component to that organization which may be highly competent and catch intrusions of all sorts, or incompetent. The Air Force Research Lab asked us to develop training to help supervisors identify cues, identify potential instances of insider threat. And so we took that rough model I just showed you a moment ago and developed a training system on this framework. That is to say, it's designed to convey some knowledge about psychosocial states that may present a threat, about environmental conditions which may provide opportunity for threat, and about security conditions that may also provide opportunity for or inhibit threats. There's some set of managerial responses that you might take, which might include going to security. They might include simple direct discussion. Those actions have costs. Those actions vary in their effectiveness. And we want to here create a training environment in which people not just acquire that knowledge by reading, but practice it, right? That is to say, they work through scenarios that require them to assess whether an insider threat is present or not present, attribute that threat to some array of the psychosocial environmental cues, and take some action. Then get feedback, then repeat. And of course, we do this without a representative sample of events in the real world, so the training takes less than 10 years. And the training looks like this. In the product that we delivered to AFRL, users first got a bit of an intro into what the insider threat is and why they ought to pay attention during this training. And then they moved into a game space in a browser, which presented an office environment within an organization of 18 people. It's an software engineering organization. There were characters in that organization. They had roles. They did things. But what mattered most for trainees is that they did what you do at an office, which is you read through email, you listen to voicemail, right? You read through reports. And buried in some, but not all, of these scenarios were clues that Mary or Josh posed an insider threat at some level of severity. And the task was to say, Mary poses a threat. We think these are the sort of behaviors related to these sorts of psychosocial cues that concern us, that cause us to raise this to security. We think there's an opportunity here, perhaps because the organization is laying off people, there's stress, right, that may be aggravating things, and then to recommend some action. The students then get some feedback, right, on whether those assessments, attributions, and actions are accurate or not, and they move on to the next scenario. There's also some reference material at the end for them to keep and treasure. So I've been talking a lot about these three constructs of psychosocial knowledge, organizational knowledge, and security knowledge. We took a very detailed approach to this. We looked to Frank Greitzer's work of a number of years ago at Battelle. Frank went around, surveyed security personnel and others to understand what the cues were that they looked for in personnel that made them concerned that there might be an insider threat. And he did some machine learning work to sort of cluster these up into indicators of psychosocial state This person is under stress. This person is narcissistic. This person is disgruntled, has anger management issues. We can look to the overwhelming business literature for constructs related to the structure of organizations, their ability to manage people well, and find the sort of things that exist in organizations we never want to work for, such as the absence of any institutional justice mechanism, such that if I am accused, I have someone to turn to make my case, to stressors, downsizing, things of this sort. And finally, we turn to the security literature for cues there concerning the state of security policies, whether those policies, even though they exist, are not enforced, and so forth. All right. So we took this very detailed set of constructs, and we built scenarios that, as I say, had cues in them to these issues. We built about 152 scenarios, really that's 76 scenarios in which the person of interest, the manager whose role you're playing, is either male or female. Those scenarios were of three types. Either there exists a threat in the organization, a person, or there's no insider threat, or there is some emergency situation. That is to say, some situation in which the normal responses are not appropriate, right? The kinds of actions you take are just qualitatively different than in a slow-moving threat. And we provided the training that I described earlier. I should say that in some work that we did internally, we took the same environment in the computer and then laid it out into a graphic novel format. So this basic method of structuring the training content can play out in any number of media. So this is a view of sort of how we made training materials. I want to dig one level deeper, right? We've gone from the student's experience in a game to the training content that populates that game. And looking at this slide about training content, you should ask yourself the following question. You have 152 scenarios, right? Which scenario do you give next, and then next, and then next? Given that, right, you happen to learn this stuff much faster than I do. You learn the psychosocial factors quickly, but for some reason the security stuff evades you. I get the security stuff, but the psychosocial is way beyond me, right? So there are any number of ways, someone here can do the math, I can't, to combine, to order these scenarios. And what I'll do now is to explain a process which we have since used to develop the intelligence that lies inside the next generation of intelligence training systems for the Air Force, right? And that's this. There's an interface on the upper left here in which instructional designers, right, specify, they both characterize the scenarios, right? So this scenario concerns psychosocial factors A and C, organizational factors 2 and 7 play, and there's security factor Q, right? And they specify some attributes of the instructional strategy, right? So at the time, the Air Force was interested in contrasting what I'll call proficiency training, in which I learn one skill with an extraordinary depth, and then I learn the next skill in extraordinary depth, step by small step, right? Inefficient, but very thorough. They wanted to contrast that with adaptivity training, in which I learn to handle problems that are wildly different, one from the other. you might still work through, every problem in that massive cube if each circle is a problem. But you would do so in a way which essentially trains you to deal with surprise. So again, there's a sort of an interface in which one describes the scenarios and describes the training strategy. There's a very generalizable mathematical formula that gets put to use to turn those descriptions into what's called a partially observable Markov decision process model and then solve it. Okay? The way I want to describe a POMDP to you is this. Suppose you had to navigate that cube, or for that matter, navigate the oceans or the air, and you wanted to do it in some optimal way. That is to say, your fuel was limited, or you would gain more from scenario Q than scenario B, whereas I'm the reverse. Right? How would you do this? The POMDP modeling paradigm and optimization approach solves that problem for all students, for all training content that you have. Right, in one massive fell swoop. That is to say, it generates what we call an instructional policy, which you can embed inside a training system that will select the next best training experience for that student at this time. And it will do so according to some instructional strategy you have here, which, as I say, in this case, concerned sort of testing proficiency training vice adaptivity. Yes, partially observable Markov decision process. Right? And it's a model which has a peculiarly nice fit to training problems because it assumes that the measures we take on student proficiency are estimates of how good that student really is, that we don't truly know. We got a rough estimate. And it assumes that the scenarios that we give students, right, will have an effect, and we have a kind of rough guess what that effect will be, but we don't really know. Partial, right. And it handles the probabilistic nature of the training problem very nicely. And also, by the way, it looks forward in time quite a bit too. So you're not just choosing the next scenario, but the next scenario with respect to the ones that follow it right up to expertise. So, building a system like this, it takes a village, which started with AFRL. They've got a human performance wing called the 711th, which is interested in these sorts of issues, among many others. Within our team, it took a cognitive and instructional psychologist, an experimental psychologist who happened to have a lot of security experience and familiarity with DoD from having taught at National Defense University. It took a computer scientist who could handle the POMDP and similar algorithmic issues. It took a software engineer who could work with that crazy array of people without losing his mind. And it took some very sharp partners. Again, Frank Greitzer from Battelle, who did this wonderful research about psychosocial states in the insider threat. A company now out of business, alas, that made a JavaScript 3D game engine, which is to say you could run it in any old browser. And Anders Ericsson, who is the Dean of Expertise. And it took some old friends at NDU to help walk through the product and say, that works for us, that doesn't work for us. So again, here was a project that took the output of good psychological research into a cyber problem, the insider threat, used it as part of a larger structure of the knowledge one needs to have to assess threats, right, to attribute them to causes that might be curable in different ways, and to take actions to apply those solutions. And there we have it. Thoughts, questions, worries, complaints?
Program operational?
It is not in use now, alas. NDU decided not to make use of it in the end, and we found it difficult to get it into institutions which saw the insider threat training problem as a compliance problem. That if the students attend one lecture once a year, that box is checked. Right? So,
It's so ironic, right? It's,
yeah.
Being more ironic that they did pay you for like building a training program, but
Yeah.
they just shelved it. So my questions were basically around building our own program like this because this is something we're going to do all the time.
Sure.
So, like methodologically, how did they gather the data in the first place that you used basically to build the model?
Right.
And then how are we going to measure actually after we build it right? How are we able to measure that effectiveness? And then maybe, and is it even generalizable? Because the data you got might even be the real magic. You might
Right.
be able to-
So there's sort of two levels of answer to that. The interesting data here, I think, is the psychosocial stuff. And Frank Greitzer and company have published a good article on this. I think it is published through Battelle. If you don't find it easily, let me know and I'll pick it out from you. As I say, Frank's interview was largely interview and survey work to try to identify those cues that worry security experts. Right? So that's a little dubious because we know that inferences about internal states are kind of dicey. Right? The last review, let's say, of ability to detect lying that I read covered 325 studies and found that human effectiveness was exactly that accurate. Right? Turns out if you take away visual cues, you get more accurate. But right? So this is why we all keep doing research to find this stuff. So the first answer to your question is read Frank Greitzer's paper. It's good stuff. Frank, by the way, also did a machine learning exercise and was able to build a system that pretty reliably detected insider threats from the data that he had. But this is a sort of circular reasoning problem here.
What data is that, though? Is it just like people's surveys? Is it like where they park their car? I mean, like what sports teams they like? Because, like
Yeah. So I think we'd probably have to talk a bit more about Frank's paper. I mean, just to again, the summary is he tried to understand what worried security personnel enough to say there's a potential insider threat, right? The other question is how did we validate the training, right? And there are three ways to do this, of which we did two. One, we did a computational study in which we built a model of a student and ran the student through different versions of this training, basically, with the adaptivity on and off. The second, we took it to people at National Defense University who teach security, who we figured either might know or at least would know what's acceptable to their students, right? The thing we did not do, unfortunately, is to run the study of 40 or 80 or 120 students, right, to see. The good news is we're starting to do that with this engine underneath an Arabic language training device. And I believe we're going to do it with the Air Force's intelligence training system as well. So we'll see. We have, by the way, validated it on another Air Force application, which was dynamic targeting cell operations, which is the little crew of people who look at incoming data from the field. They have a large set of volumes to one side, which is the day's air tasking order, which took 48 hours, 72 hours to construct. And their question is that white van enough of a likely target for us that we ought to abandon today's air tasking order and get that thing, right? So high-cost decisions over highly uncertain opportunities. And in that domain, we got some really nice marked effects from this sort of adaptive training as opposed to standard Air Force approaches.
Who's your program manager again?
Dee Andrews, now retired. You may be consulting a bit.
Do you know who replaced him in that area? Because if you do, I can talk to him about it.
That's lovely. Why don't I, we talked about Scott Galster earlier. Scott's the likeliest guy. Why don't I check in with him and we'll figure out who that might be. Good. Sir?
Yeah, Jared, so since you shared with us the fact that your customer didn't employ this value of it because they don't give what's under the hood of your product or somebody else's product. You got any comments on that?
Yeah, so that's,
All aspects of
yeah.
that'll be one of the phrases we use.
Right. So first of all, you've just voiced one of several theories about why things don't transition. And anyone who's in DoD, doing research funding will probably have a good long list. The surface features of the tool can be wrong, a bad fit for the customer for some reason, right? It just doesn't look good to them. They don't understand or trust the innards, right? So I'm going to point here to this being one instance of a wickedly large case. We do a great deal of work on a DARPA program called Plan X, which is creating the next generation of defensive cyber operations tools. There's an immense amount of algorithmic work going on under the hood to try to do things like, tell you where you ought to be watching for activity, right? Does anyone know whether operators will trust the recommendations that come out of Plan X? That's a good question, right? How much judgment they'll exert and where, and what effect their judgment will have on the operation of the algorithms? Also good questions, right? And then there are the usual questions one has in marketing, right? Am I with the wrong person at the right time, the right person at the right, it goes on and on. It's a really deep problem. ONR struggles with it, I know. AFRL struggles with it. Army doesn't do as much technology training, but all of these folks struggle with it. Ma'am.
It's kind of to the first gentleman's question too. The sampling that you use to catch your problem children, shall we call them. So, first of all, there's been, I guess, some evolution of some of our insiders because each time we get caught, first it was like somebody like Oliver James who was really easy to find, and then it gets a little more complex, and you had Hansen who, had certain traits common with Ames, so we could add that to the mix there, and then we had Snowden, who was different than both of those, and now we have the new one, Winner, I think's her last name, who doesn't seem to fit any of these profiles. So how do you update, and also, there's got to be a group of insiders in there that we just don't know about, too.
Yeah. So there's the distributed insider, right? That's a particularly troubling prospect, and in which some of those members of a distributed threat are not aware that they are part of a threat, but are. I don't have a good answer to that. Frank's approach, Greitzer's approach, as I say, was to talk to security experts who might have seen it all. Though, as I pointed out at the beginning, right, if they had a representative sample of human behavior, then one out of every 173,000 employees they'd ever been with was potentially an insider threat. Right, how we handle the dynamism in this domain is not clear. My guess is that human psychology will, for once, be relatively stable, that is, relative to the technological environment that insiders exploit, and thus stable relative to the security environment. Organizational policies may be fairly stable, but I'm not quite sure. I mean, we're seeing a sort of sea change in how people are distributed over the face of the globe and still working on the same project, that sort of thing. So, all right. Yes, please.
You were discussing before about the user's perception of how trustworthy recommendation is from an algorithm or from a machine. It's probably to thinking about some work that we have done about generational effects, and I think this is very new to cyberpsychology. We found in a military decision-making environment that the more senior decision makers really want to have a personal relationship
So I wish I knew the sort of generational literature, but I can draw two things from the literature on expertise that might be relevant. And the one is, of course, that one's knowledge structure, one's ability to think and so forth, are in some large part a product of one's experiences. So there's a training question there. What's the minimum training it would take to make me behave more like one of the folks who's a student here, who's, say, under 30, right? Right. There is, of course, a question, and this is the second point from the expertise literature. I'm going to make the wild and crazy bet that the more senior folks that you talk to were in positions of higher responsibility, right? Their decisions mattered more. And it may be that both the import of their decisions and the character of the problems that they were dealing with, because of the level they work at, required them to tap a human network. I will say that we saw this in some research I did for Bell Labs years ago in, of all things, software engineering for maintenance of the phone system, which at that time was the largest machine on the planet, right? One of the very surprising findings was that the most expert of software maintainers were very quick to turn to people. So if you get a new problem, the first thing you do is you find the guy that wrote that code, and you find the team that engineered the hardware it was running on, right? And then you find out that the hardware has changed, and so that part of the code no longer works as it used to, right? It's a rare day that your problem is something you can find with lint, with a syntax checker. The problem often lies in the people, their assumptions, which are not documented anywhere, right? And it only shows up in extraordinarily bad behavior in rare circumstances. So at any rate, what tasks could you give older folks to adopt an attitude and a behavior of a younger generation, assuming that behavior matters, right? And for the tasks, should you, right? So.
And I'll comment on that as well, because I've run some programs where we had to talk to senior people about what they would think about their decision making. And if you're talking to senior leaders, they make a wrong mistake. You can talk about hundreds and thousands of people who act in very negative ways. And the young people just are not at that level yet to make those kinds of decisions. So if you're asking a general to, have faith in this mythical weapon that you've designed through human psychology versus I could drop a bomb and take that thing out. Guess which one they're going to go for? You got to think that way.
Yes, please.
I'd like to maybe equate this a little bit to the concept of crew resource management,
Good.
which developed in the 1970s.
Yeah.
Delta Airline being one of the first to, or the first to adopt it, and it took another 15 to 20 years before other airlines really started to embrace it and then expanded beyond the cockpit. So, having done some similar work at Castle,
Yeah.
we confronted very similar problems of translating it into action. And I think it's perhaps sad to say, but it might take another event for people to realize, more events for people to realize the importance of it. Because it's been my experience that events trigger as opposed to threat of events.
Yeah. Yeah, you'd think we'd had enough events already, right? But that seems not to be the case. Yeah, we do a lot of computational modeling of organizations. And that work started out innocently for the Navy, actually, in 1995, looking at just the human beings in command and control organizations. And the latest work for DARPA is explicitly about human-machine organizations. And so the crux of the matter for those who lead those organizations is, do I understand my resources well enough to put them to the right use and put them together for the right uses, where those resources might be human, they might be machine, right? It's a tough problem. Right? Tough to architect those organizations and really tough to use them well. And you're right, it all ties back to crew resource management. Do you understand your resources? Right? Can you push and pull information? when it's needed. So, good. All right, folks, thanks.
Thank you very much, Jared.